welcome everyone. Some of you, or maybe all of you, I don't know, were attended my last talk, the part 1 of this series, on why I think TypeScript is the only good solution for writing front-end code and how to do that. And since I apparently had so much to say, I got to have another one. We'll see how long. I think I will manage to fit everything in this time. Yeah. Let's start with a small recap. Typing stuff. You type stuff in TypeScript by writing a colon of the variable and writing your type. And it can be primitives, like in this number case, or it can be your own types, as in this, my object type. You type functions by typing the parameters one by one, and return type of the function by typing after the parentheses. And you don't need to type everything. TypeScript is really strong at inferring types based on usage. So the first case here, we don't need to specify that it's a number, because TypeScript knows that 6 is indeed a number. We talked a bit about discriminated unions, as they are called, where you have two different interfaces where they both have the same key, but the value is hard-coded. The user always have a member type user, and the company always has a member type company. And then we can make a union type out of these two, like we say, a member is either a user or a company. That way we can use some logic to differentiate between them. And a question that arose last time was that can't you just switch on the type, the actual type, without having a literal property? Something like this. Say I have a function called printName that takes in a member, which is a union of user or company. And then I write if type of member equals user, do something. No, this does not work. TypeScript needs to be able to transpile down to plain JavaScript, and this doesn't make any sense in JavaScript land. The type of operator only works for built-in JavaScript types. So you can do like this if it's a number or string, but not your own types. So that's why we need this discriminating literal string. Right, enough of the recap. Let's go on. And I'm going to talk about a way of solving this without having to have the literal type every time, or checking the type. And that's something called type predicates. Let's start with how you would write in JavaScript, and then we can sort of extend that to TypeScript land. Say we have, in our system we have events and payments, and this is an example, not exactly, but example of a problem we faced in Swish, where we had a function that could take in either an event or a payment and then did something different depending on the type. So in JavaScript, we might do something like this. We create an isEvent method that takes in this event or a payment, and then if the key event type exists in this object, return true. So we know that, oh, if that object has event type, we know that it's an event. And then in our function that takes in event or payment, we can check by just calling this function. Oh, is this an event? Then do something with event. And then another case for payments. So if we extend this to TypeScript, we start by creating an interface for our event type, which is, it has an event type and it has a data property which is in turn an object with a payee, which is a string. And we create our event, which we might get from an API or anywhere. We also create the interface for payment type, which is just an amount and a message, and then create an object for that. Our isEvent checking method now. Here we extend so that we declare that the event or payment we are taking into this function is either an event type or a payment type. And then we do the same thing. If event type exists in this input parameter, let's return true. And then in our do stuff method here, where we take in, we're not sure if we get an event type or a payment type input, we can check, oh, is this an event? Then do something with the event type. In this case, this will throw an error because the type of E inside of this is still event type or payment type. Typescript doesn't know based on this that event type or that the event is actually an event. But Typescript has a solution for this with just a small addition up here and in the signature for the checking function. We can add a type. E is my event. And it shouldn't say my event there, I realize. It should be event type. Copy-paste errors. So here we say that the return type of this, if this method returns true, then this will be an event type. If it returns false, it will not be. So now then, when we call this event down here, we can see that Typescript has realized that, yeah, the isEvent function is a type predicate and it returned true, so then E in this case will be event type. So this is another way of narrowing types, as we talked about last time, where we have a union, but we want to do something in the different paths. And I should have said before perhaps, but feel free to interrupt if you have any questions directly, or write them in the chat, or wait until the end. Last time we also looked at some hard to read types. So if you hover over a map function on a numbers array, you will get this this definition, which is a bit daunting. So I thought we'd break that down step by step to see how you can trying to parse built-in types. First, I've just removed the method in parentheses because that's just a label category. And then I've removed the generics, which I will talk on a bit later, but for simplicity's sake here, let's just assume that we have an array of numbers and that our map function returns a number as well. So we get a number array back. And then I've refactored out the callback function to a separate type. And a map callback function is, as you most likely have encountered, a function that gets a value, index, and an array as parameters. The value is the current element of the array we're looping through, index is the current index, and array is the whole array. And it returns whatever you return from the function. In this case, we have returned a number. And now the definition, the type definition of the map function is quite easy to read. It's a method on the array class that takes a callback function and an optional this argument, which we most likely never use, and which returns an array, in this case a number array. So even though built-in types might seem daunting at first, try to, as with any unknown code, right, break it down and refactor until you understand. There are a lot of really complicated types, of course, so this is not always helpful, or you're not always able to figure out what it does, but most of the time you can at least get some information. So let's talk about generics then. Generics are a way of passing arguments to a type. Just like you are passing parameters to a function, in this case you're passing 5 to my function as an input parameter. We can do that with types as well. And the syntax for that is, when you define your function, you add the angle brackets before the parentheses that says t, and that can be any name, but t is the sort of norm naming convention of using a generic type. And then you can use this t anywhere in your function. In this case, I've said that, oh, the input will be of type t, but it can be anywhere inside of the function or the type. And then calling our my function with a generic, we can see here that in the first case I've specified that t in this case is a number, and I've passed in a number, and the second case a string, and I pass in a string. And here we would get an error if we were to write my function number and then pass in a string. Then Typescript would say that, oh, those don't match. In this case, though, you don't need to specify the generic. Typescript is again able to infer the t value of the t type from the input parameter. So if we hover over my function here, we will see that it has a generic of a Boolean. An example from my own code where I've used generics is in my error handling. Say I have an interface that defines an error message with a code in the message. And then I have a generic type called success result with a generic type t here. This is a bit different from passing a generic to a function. Here you add the generic afterwards, after the type name. And my success result is success is always true, and data will be of type t. And my error result in the same way is success false in this case, and it doesn't have any data, it has an error with the type error message instead. And then I've made a type called maybe, which is either a success result of type t or an error result. And my services fetching data from APIs are using this maybe return type. So I know that I don't need to specify a separate return type of all different kinds of API responses, but I have a generic one that I can reuse. So if we go back to this complicated map type on the array, we can look at the actual definition. If you command click or whatever keyboard shortcut you use in VS Code on the map function, you will get into the standard type definitions for JavaScript, and you will look at this and a lot of other stuff, but this is just a map function. So let's go through this and see how the definition actually works. I'm going to start from the other way now and build up to it. So our interface array, let's remove the generic type t first. It's an array, and I've said that the interface array has a map function that takes in some arguments and will return an array, because a map function returns an array, right? And the map function can transform any array into another array of another type. So if you map over a numbers array, you might return a string on each element, and then the resulting array from the map function will be an array of strings. So we need to specify the return type here. So our map function takes in a generic, and that generic is what will be returned. So every iteration of the map will return U in this case, and after the whole map is run, it will be an array of U's. And then we add back our callback function, since that's the argument. I'm gonna skip this arg here because you never use them. So here we have the callback function, which is of type callback function. So how does that look? Here I've just refactored it to a separate row because I didn't have room. So callback function, let's extend that. So the callback function is, as we saw before, a function with 3 parameters that returns something. We have a value, which is the current iteration value, the index, which is the current iteration index, and the whole array. And remember that our array can be of any type T. In our example, a number array. So every iteration of this map function value will be of type T, since it is a T array. Index will always be a number, and the array will be a T array. And we're returning U, because U is not necessarily the same as T. And there we are back at the top definition. So here it's a nested generic, where we have a generic array type and then a generic map function. And the callback function is using both of those. Let's go on to some error messages. One of the biggest hurdles of new TypeScript developers are the really long and complicated error messages. I spent last evening working on a hobby project, which I got, I think, an error message of, I don't know how many rows, 15 or something. A bunch of nested types from a library didn't match another type. Yeah, it was a mess. But let's step through how TypeScript actually works in their error messages. So last time we had this example where we had a mixed array type, which is either a complete array of numbers or a complete array of strings. And if we try to do an array of this type but enter both numbers and strings, we will get an error. And we will get this error below. So TypeScript's error messages is by increasing specificity. So the first row says that an array of either string or numbers is not assignable to my mixed array type. And this string number array is the inferred type of the right-hand side of this assignment. So the type of this array is an array of either string or numbers. And that's not assignable, but my mixed array type. And then it clarifies that, okay, it's actually, because since my mixed array type is a union, this inferred type is not assignable to number array, which is the first part of our union here. If we were to define these in the other order, which is perfectly fine, this would be triggered on the string array first, since both of them are incorrect. And the next step is more specific. String or number is not assignable type number. So in the previous example, we had an array of string or numbers is not assignable to an array of numbers. Oh yeah, and that's the reason for that is that string or number is not number. And even further, string is not a number. So you sort of read them. The most information you can get is in the last row. that's where the actual type error is. And then you can step up to see where that type comes from. But this is hard. And there are some initiatives to try to make these kind of error messages more human readable. There's a plugin called Total Typescript for VS Code, I think, which tries to give more reasonable error messages. So it's a work in progress. But as with any language, the more you work in it, the more you understand them. I'm gonna go through a couple of utility functions because TypeScript comes with a bunch of them built in. So say we have this union of fruits, apple, bananas, and mangoes. We can use the exclude utility type to define a new type, like type tasty fruits is from fruits excludes mango, and from that we will get the type apple or banana. We can also do the other way around. We can make a new type called actually not a fruit and extract banana from fruits. And the comment here is wrong, it should say banana. Because we get banana from this. And that type will just be a literal string called banana. If we have an interface fruit with a name, color, and a tasty boolean, we can do sort of the same thing there. We can use omit to remove one of the parameters. So basic fruit will be an object with only name and color, since we removed tasty. And if we want to get the type, the fruit name, we can pick that object, that property. And in all of these cases, we can use unions in as the last parameter. We can pick name, pipe, color from fruit, and then we will get both of them. There are a bunch of other utility functions like return type from functions or parameters from functions, and nullable types, record type, which we will see. No, we won't see. I changed that example. Right. There's a lot of them. Look in the handbook. They are useful. It's like array manipulation, but with types. Last time we spoke about an escape hatch, which is when you know better than TypeScript. Like in this case, we fetch something from an external API, we convert that to JSON, and the TypeScript will type that as any. And here we know that, okay, but that endpoint returned user details, so I will return data as user details. And that's usually fine. The problem is that you can get unexpected errors if the API changes structure. So a way to mitigate that is to introduce Zod, which is a package for typing API responses or typing any unknown objects, really. So you start by installing Zod and then import Z or Z perhaps. Then you define a schema. Say our user schema is a Z object, which has a username, and that username is a Z string. And then we create our get data function that will fetch the data from the API and return the user to us. The first thing is the same. We fetch from some external API and convert that to JSON, and data here will have any as a type. Then we call safe parse on our user schema with the provided data. And that will give us parsed user. So what does this return? Parsed user returns, and I'm simplifying here, a type basically like this. It returns a parse result, which is either a success user or an error user. and the success user is success true and data something something. And this is quite similar to my own error handling from before. And the error user is success false, and the error will be of type SOD error. So back to our API function. Our parsed user here is now either a success user or an error user. And then we can just check if parsed user.success is false, then log the error and throw an error or do whatever error handling you want. Print a pretty error message to the user saying something went wrong with fetching data, fetching user details or something. And in the else statement here, parsed user success will be true. So therefore, parsed user.data will exist and be of type username string, since that's what we defined in our schema. So this is a really powerful way of making sure you get the correct data out of your API and making it type safe for real. So our get data will return our user details type, since it's gone through this SOD parsing and typing. So I can highly recommend SOD. It's very strong. When we're writing code, we're not writing everything ourselves. We usually use a lot of libraries. And I know that you app people tend to make fun of our node modules folder with thousands and thousands of dependency, but that's the way it is. Let's have that fight other places. Most third-party libraries nowadays specify their own types in their package. So you actually, when you use something, you get types automatically. Some don't. Here's a screenshot from Style Components, which is a CSS and JavaScript library. On their section of TypeScript in the docs, they say that Style Components has community-organized TypeScript definitions on definitely typed, which powers the editing experience in IDEs and can provide types for TypeScript projects. To install them, run npm install types/style components. And this namespace types here is definitely typed, which is this, as the text here says, this huge repository of community organized TypeScript types for so many libraries. And it's very impressive to see that it's managed to stick to one library for all types, and you have sub libraries depending on project. So if you experience that you don't get any type safety if you're using a third-party library, check on definitely typed to see if there are types there. And don't, as I mentioned before, don't be afraid of checking the actual types from the libraries. If you get weird error messages from a library, well, dig into their type definitions and see what's going on. If we command click into safe parse, the ZOD example from before, we see that we land in the folder source node modules zod lib and then the file types.d.ts. And the ending there, d.ts, is a TypeScript definition file. Because when you are publishing a library, you are transpiling, even if you've written your types, your library in TypeScript, you're minifying that and transpiling to JavaScript, and then there's no type safety left. So what you do is generate a type definition file side by side, which is just the types. So here we see that safe parse takes in some data of an unknown type, our API response, and some additional params if needed. And it returns safe parse return type input output. So let's command click into safe parse return type. That is as I've described in my pseudocode, it's a union of safe parse success or safe parse error. Where safe parse success looks like this: success is true and data is of type output. And safe parse error is success false, and the error is a ZOD error with the input as a type generic. We can keep going if we click into ZOD error and check that. There we'll see that ZOD error is a class that extends error. And error in this case is the standard error in JavaScript. So it has all the message and code from the error class, but also adds something. In this case, it adds the array issues, which is, well, everything that went wrong when parsing the result. And you can use that to log the actual error or give the user some details what went wrong or so on. So it's really nice to be able to look into these definitions. You don't have to be in the dark and try to just figure out stuff by hovering or autocompletion. Have a look at the types. And there might be really hard to parse type because some libraries have really advanced TypeScript usage, but you can usually get something out from it. And lastly, I'm going to talk a bit about integrating with frameworks, Vue and React. In React, it's really straightforward. You define an interface with your props and say what your React component will get, what props they will get. And then you type your React component with react.fc and pass in your prop type as a generic. And then you will get completion for all props, and you will also get error handling if you don't pass the correct props and so on. Enabling TypeScript in the React project is also very straightforward. Have a look in the React docs on that. It's basically flipping some config options and adding a tsconfig file. In Vue, it's basically the same thing. You start by specifying the language in the script setup tag or script tag, here lang ts for TypeScript. You define an interface for your props, and then you call the function define props, which is a built-in Vue function. And then you will get autocompletion in your code. And it's the same as React. It's really not a hassle to set it up in Vue. Just check their documentation. And look at that, I'm done well in time. So here are some resources. The TypeScript handbook, I linked that last time as well. Zod, you can find on zod.dev, and you can find these slides on py.fyi/talks. And then I can open for questions if there are any.